Hello guys and welcome back to this second recording. Here we're going to try to find out the required in question number 6, and the question is about the measures of 4 interior angles of a pentagon are 70, 100, 110 and 135 degrees respectively. What is the measure of the fifth interior angle? So here we're talking about the sum of the measures of the interior angles of a pentagon, and actually we know that from the previous problems the sum of the interior angles of a pentagon equals 540 degrees, and actually we know why they are equal to 540 degrees. Okay, so the required is to find the fifth interior angle in the pentagon. So I can say that the measure of the fifth angle equals the entire sum of all interior angles, which is 540 degrees, minus the sum of the given interior angles lengths, which is 70 plus 100 plus 110 plus 135, and the required will be 540 minus their sum, which is 415, and the length will be 125 degrees. Question number 7 is about the ratio and similar triangles. Here the ratio of side length for a triangle is 3 to 4 to 6. In a second triangle similar to the first, the median length of a side is 10 centimeters to the nearest tenth of a centimeter. What is the length of the shortest side of the second triangle? Guys, here we're talking about two triangles. The first one, let me sketch it in blue. So this is the first triangle, okay, and we're not given the actual length of its sides, but actually we're given the ratio between these sides. So the shortest one will be this one, which measures actually 3x, where x is the we can call it a scale factor, we can call it a constant of proportionality, whatever you want to call it. Okay, so the middle one, the median length, measures 4 multiplied by x, and the longer side measures 6x. Okay, and the second triangle, I will sketch it in red. The second triangle is similar to the first triangle, and actually we're given the length of the median or the middle side, which is 10 centimeters. So guys, let's have a look to these two similar triangles. Okay, once we're given that these two triangles are similar, then their corresponding sides must be proportional. So I can say that this side is corresponding to this side, so they must be proportional. So I can say that 4x over 10 equals 3x from this triangle over its corresponding side in this triangle, which is actually is not given and it is required to be found. Okay, and I will call it y. I will give it the variable y. From this relationship we can simply apply the cross multiplication. So 4x multiplied by y, y is the required side, the shortest side in the second triangle, so simply equals 4xy, and that must equal to 3x multiplied by 10, which is 30x. Okay? And now we can cancel out x by dividing both sides by x. X cancel out x. Okay, leave me with 4y equals 30, and from that we can find out the value of y by dividing both sides by 4. So y, which is the smaller side, equals 30 over 4, which is 15 over 2, which is equal to 7 and a half. This is the measure of the smaller side here in the second triangle, equals 7 and a half centimeters. Let's go further to the question number 8, and question number 8 is about dilation. Here we're given two figures. The first one is the original figure, and the second one is its image after a dilation. Triangle B prime, Q prime, R prime is the image of triangle BQR after a reduction. Find the value of x. And here we're given these dimensions, and the required is to find the value of x, which is the length of the side QR. What is the length of QR? So, guys, we know that dilation results in similar polygons or similar figures. So, these two triangles actually are similar because one is the image of the original one by a dilation. Okay, so we can apply proportional relationship between these two figures. And here we're given the length of this side equals 6, and its corresponding side actually, which is QR, which is the required to be found. So the image length is the length from the center of dilation to the image, which is P prime, and that equals 8. And the length from the center of dilation to the original figure is 14. So we can apply this proportional relationship, okay, which is let's say Q prime R prime equals QR must equal to the image length, which is C P prime over CB. Okay, so Q prime R prime equals 6. QR is not given, and actually it is the required, and it measures x. CP prime equals 8, CB equals 14, and we can apply the cross multiplication. So we'll have 8x equals 6 multiplied by 14. Let's simplify. 8 divided by 2 equals 4, by 2 equals 3, by 2 equals 2, by 2 equals 7. So we can say that x equals, we can say 2x equals 21, and then equals x equals 21 over 2, which is equal to 10.5. So x equals 10.5, and you can check this cancellation out using your calculator. Let's go further. Here we have a cylinder, okay, and the length and radius of a horizontal right circular cylinder is given in feet in the figure below. What is the volume of the cylinder in cubic feet? Okay, since we are required to find out the volume of the cylinder, I think the first step is to write down the formula. How to find the volume of the cylinder? The volume of the cylinder simply equals base area multiplied by height. So, first thing you need to find out is the base area. And since the cylinder has a base of a circle, let's find out the area of the base of the cylinder, which is the area of the circle. يبقى هنا base area simply equals by r squared equals by, and the radius is given, which is 3. So the base area equals 9 by, and the unit here is feet squared. Okay, and let's go and substitute for the base area here by 9 by. So the volume of the cylinder equals base area, which is 9 by, multiplied by the height, which is given, which is 12. So the volume of the cylinder equals 9 multiplied by 12, which is equal to 108 by cubic feet. And this is the required.